To understand Mangalayaan's success, you have to look under the hood, literally. What India achieved was not just the launch of a spacecraft, but the crafting of a masterpiece of compact engineering. In a world where space missions often run into billions of dollars, Mangalayaan's sub-$75 million price tag forced creativity, innovation, and efficiency at every level. Let's break it down. At its heart, the Mars Orbiter mission, MOM, was powered by a single solar array consisting of 3 panels generating about 840 watts of power. This electricity not only fueled the onboard systems, but also charged the lithium-ion batteries used during eclipse phases. These energy-saving decisions helped minimize power loss and extended the life of the mission far beyond its original 6-month timeline. The spacecraft's propulsion was equally lean. Instead of large, complex propulsion units, it used a single main engine along with 8 small thrusters for attitude control. With a fuel tank capacity of just 852 kilos of bipropellant, it had to perform an Earth orbit raise, a trans-Martian injection, and Mars orbit insertion, all on a single shot. And it did. One of the engineering marvels of Mangalyaan was its lightweight structure. The dry mass was just 475 kilograms, including 5 scientific instruments. The entire system was constructed using composite materials and modular components, which made it easier to test, replace, and integrate on a tight schedule. MOM's onboard computer used radiation-hardened processors running real-time control software. These processors weren't bleeding edge by global standards, but they were reliable, power-efficient, and robust enough to withstand the rigors of deep space. Importantly, redundancy was built in. Backup systems could take over instantly in the event of any failure. Thermal control was handled passively using multi-layer insulation and specially coated surfaces. With no active thermal regulation, every surface was meticulously planned to manage heat flux between sunlight and shadow. But the real stroke of genius lay in ISRO's reuse philosophy. Many of the systems on Mangalyaan were adapted from India's previous missions, especially Earth-orbiting satellites. This meant that the engineers were working with proven hardware and software, significantly reducing the chance of failure. All communications with Earth were handled via a high-gain antenna operating in the S-band and X-band. Despite budget limitations, the spacecraft maintained regular two-way contact with the Indian Deep Space Network, located near Bangalore. Telemetry data streamed in, showing consistent health across all systems. Infinity Beyond celebrates this part of the mission not just for its scientific outcomes, but for the blueprint it offers to emerging space nations. Mangalyaan showed that ingenuity, adaptation, and precision can stand shoulder to shoulder with massive budgets. Every bolt, every line of code, every weld on Mangalyaan told a story, not of compromise, but of clever engineering. It didn't just reach Mars. It proved that space belongs to anyone willing to solve problems smartly.